Another very important concept that you're going to need to know for your SATs is the idea of special right triangles. So special right triangles are right triangles that have certain proportional rules that are going to be applied every single time that you see one of them. The two special right triangles that you need to know are called 30-60-90 and 45-45-90. And the reason why they're called these is because of their angles. So a 30-60-90 has one 30-degree angle, one 60-degree angle, and one 90-degree angle. Now the way that we're going to look at these is they're going to be given, each of the sides are going to have a special relationship. The sides are going to be a square root of 3, and 2a. So here's the way I want you to think about this. If you have a square root of 3, that's a times the square root of 3. What you're doing is you're taking one of the sides, or the lengths of one of the sides, and multiplying it by square root of 3. So the square root of 3 is greater than 1. So since the square root of 3 is greater than 1, that means that this one is going to be bigger than this one. Since the square root of 3 is less than 2, then you know that it's also going to be less than this one. So the way that this works is that the side that is across from 30 degrees is A. The side that is across from 60 degrees is a square root of 3, and the side that is across from 90 degrees is 2a. So those are the relationships. So again, smallest angle is across from the shortest side. Largest angle is across from the longest side. Come down here to 45, 45, 90. Now what I've done here is I have not marked them with 45-degree angles. What I've told you is that you have congruency markings on these two angles. So anytime that you see congruency markings on those two angles that are not the right angle, and obviously the right angle cannot be congruent to another angle in a triangle, these two angles have to be 45 degrees since they're congruent, because they share the remaining 90 degrees, and you have to divide it by 2, so those are going to be 45 degrees. So just because it doesn't say 45 degrees does not mean that you're not expected to know what these congruency markings tell you about this triangle. Now what we're going to do with this is an isosceles triangle by definition. Because our base angles are congruent, that means that the opposite sides are also congruent. So this one is going to have the relationship of a, and a square root of 2. So that means that our leg is going to be a, our second leg is going to be a, and the hypotenuse is going to be a square root of 2. Now what I'm going to do in the next few problems is show you how this works. Again, it's incredibly important that you learn how to do this concept, because this is going to save you tons and tons of time when you hit the SAT. So in problem number 1A, you can see that we're given a 45, 45, 90 triangle. We are told that A is equal to 9. Well, we know that H is equal to a square root of 2. So what is the value of A? The value of A is right here. 9 is equal to A. So all we're going to do is plug 9 in for A. So that means that the hypotenuse is 9 square root of 2. And you're done. That's all you've got to do right there. Because this is now in lowest radical form, and we've gone ahead and filled in what that variable is. Okay? Now the second problem that we've got here is going to be more complicated than the first. Because what we're given here is, instead of a regular old integer being the length of the side, or the a value, we're instead given 2 square root of 2. But you're going to follow the same rules. X is equal to a square root of 2. This entire thing right here is a. 2 square root of 2 is a. So you're going to take this and replace a with that. So when you do that, you're going to have x equals 2 square root of 2. Do not forget about this square root of 2 sitting out here. This square root of 2 and this square root of 2 are not the same thing. So you have to multiply that by the square root of 2. So square root of 2 times square root of 2 is square root of 4, which is 2, times this 2 is 4. So x is equal to 4. Okay? That's how you're going to do those right there. You know what the A value is, then you need to figure out what is the proportion that this hypotenuse is equal to. It's equal to a square root of 2. So take your A value, substitute it in for A, then work out your problem. Now coming over here to problem number 2, we are given X is our side and 6 is our hypotenuse. So again, what we know is that X is equal to A, and A square root of, or 6 is equal to A square root of 2. Okay? So all I'm doing is saying that this side is equal to this part of the proportion. It's equal to A. Then I'm saying that this side, which we know is 6, is equal to this part of the proportion. So now I've got to figure out what is the A value. Once I know what the A value is, then I know what the side is. So how are we going to work this out? Well, remember that anytime that you've got something that looks like this, I'm going to go ahead and rewrite this as a square root of 2 equals 6, so it'll make it a little bit easier for me to work out. I need that square root of 2 is being multiplied against the A. So how do we get rid of multiplication? We're going to use division. So we're going to divide out the square root of 2. Well, what that's going to leave us with is A equals 6 over the square root of 2. But if you go back to your algebra, you're going to remember that you can't have a radical in the denominator. So you're going to have to rationalize this denominator to get rid of that radical. In order to do that, we're going to multiply both the numerator and denominator by that radical. So square root of 2 and square root of 2. So 6 square root of 2 over square root of 2 times square root of 2 is 2. Now we can reduce the 6 and the 2, so this becomes 3 square root of 2. So A is equal to 3 square root of 2. Our side is 3 square root of 2 units long. So what you've got to remember is to set your stuff equal to the proportions. So X is equal to A. Well, there's nothing we can do with two variables, so look at the hypotenuse. A square root of 2 is equal to 6. So we know with only one variable, we can solve for that. Go through the process, rationalize it, and this is what you get for this side, 3 square root of 2. In problem number 3, what we're going to be looking at is if you've got a softball diamond, what is going to be the length of the throw from home plate to second base? And we're told that the length of the base path, so from home plate to first, from first to second, second to third, and third to home, is 60 feet in softball. And so what we've got to do is we need to figure out what is the length of the throw from here to here. So we've got to do that with just this given piece of information. So in order to be able to make this work, what we have to do is use an auxiliary line. And I'm going to draw an auxiliary line in from home plate up to second base. Now what this is going to do is it's going to split this diamond, which is just a square that's been rotated 45 degrees. It's going to take this diamond and it's going to turn it into 2 right isosceles triangles. Now if it's 2 right isosceles triangles, that means that these angles here are going to be congruent. Okay? So if they're 2 right isosceles triangles, and we know that the 2 angles that are not the right angle are congruent, then we know that we've got a 45, 45, 90 triangle. At that point, it just becomes a matter of using our proportion. So we know that our proportion is A square root of 2. So what does this 60 represent? Well, the 60 is one of the legs of the right triangle. So that means that A is equal to 60. So if A is equal to 60, how do I know what the length of the throw is? The throw is going to be, we're going to take this 60 and plug it in right there. So A square root of 2 is going to be equal to 60 square root of 2. Now in this case, this is a distance problem, so you would want to go ahead and convert this over to a decimal or convert this over to another unit. And this is going to give you approximately 84 feet would be the throw from home plate to second base. In problems number 4 and 5, we're going to be looking at 30, 60, 90 triangles. So for these, what we've got is, on our first one, we've got a length of D and a length of 5 on our legs, and then we've got a hypotenuse that's not been given. All we're looking for here is the length of D. Notice that we've got, again, 30, 60, 90, so that tells us we're going to use our proportions. So our proportions for 30, 60, 90 are going to be A square root of 3, and 2A. So now what we need to do is decide what information do we have here. Well, this D is across from 30 degrees. So that means that we're going to substitute D for A. Now the 5 is across from 60 degrees. So that means it is A square root of 3. So we need to find out what is A square root of 3 equal to, or what is the value of A. So A square root of 3 is 5. What is A? Divide by square root of 3. And then you end up with A is equal to 5 over the square root of 3. But remember, we cannot leave a radical in the denominator, so we've got to go ahead and rationalize this. So again, multiply by the denominator. So multiply by the square root of 3 and the square root of 3, and we get 5 square root of 3 over 3. So that is the length of A. And since A is D, D is 5 square root of 3 over 3. In problem number 5, you're given that somebody is given a pendant, so a little necklace or a charm on a necklace in the shape of a triangle. And we know that the height of the pendant is 18 millimeters. What we want to do is we want to find out what is the length of one of the sides of that pendant to the nearest tenth of a millimeter. So what we're going to do is, again, just follow the rules that we've already got. We're given in this that we have a 30, 60, 90 triangle. And so what we can say here is that if this is the 90, then this is going to be our 30 here, and this is going to be our 60 here, because this was an equilateral triangle. When we take an auxiliary line and put it through that equilateral triangle, what we're doing is we're taking a 60-degree angle and we're bisecting it. So that means that this bisected angle becomes 30 degrees. Then we have 60 degrees down here and 90 degrees over here. So now it's a matter of figuring out what information do we have and what information do we need to find. So if we go back again to our proportion, A squared of 3, and 2A. What we're going to see is that across from 60 we've got 18. So that tells us that A square root of 3 is equal to 18. What we're going to be looking for here is the side that's across from the 90-degree angle. So we're looking for 2A. Right, so what we need to do is find A, and then we can plug it into 2A and then figure out what the length of this is. So divide by the square root of 3, and you get A is equal to 18 over the square root of 3. Again, what we need to do is get rid of this radical by rationalizing. So multiply by the square root of 3 over the square root of 3. That gives us 18 square root of 3 over 3. Now these can reduce, and we get 6 square root of 3. So we know that the A value is 6 square root of 3. So if we were looking for this side right there, we would know that that's 6 square root of 3. But we're not looking for the side across from 30. We're looking for the side across from 90. So what that tells us is to go back up to this one and go 2 times 6 square root of 3. So 2 times 6 is 12, square root of 3, and that's going to be approximately 20.8 millimeters in length. So that's how we're going to find the side when we're given one of the other sides or when we're given the hypotenuse.